Hi, hi. Hi. Sorry. So I'll just start the questionnaire. Did someone come and leave in between, or were you the only one at this time? Okay. So we'll just okay. And you don't have a problem, right? I mean, I have to do it anyway, so I might as well do it with the, with a single person, with a single attendee. So I'll just start the question. It would be okay. So yeah, the first question is on your screen right now. Sorry, this is the second question. I'm sorry. Ah, okay. So yeah. So the thing is, no, it's not none of the above. The answer is A. No, the answer is A. So basically, specific gravity greater than 1 would mean that the hydrocarbon actually, the oil spills actually do not float on the water. So what happens is, if they don't float on the water, they are not exposed to sun and air, atmosphere. So they don't. There's a greater there's a lesser chance that they will actually break down. So they'll sink into the bottom, and they'll start settling over there, which is more harmful for the creatures at the bottom of the ocean, the floor. So the ones that float on the sea have more chances to be exposed to sun and break down eventually. So which is okay, because they also spread a little, and they are because they are hydrophobic, they also spread a little, and with UV rays and atmosphere they break down. So floating hydrocarbons are still okay. The ones that actually sink and reach the bottom are more harmful. So the answer is A. So they do not get exposed to sun. I hope that's okay. I'll move on to the next question. Yeah, this one's simple. Yeah, this is simple. I don't think we need any more explanation for this. All right. I'll move on to the next one. Yeah. Okay. So the answer is 9%. No, it's not B, it's C actually. And 20 and 30% are too high for, I mean, for recycling. To be exactly the amount of recycled plastic globally. 9% is the exact amount. And yeah, this has been taken from Current Conservation, the one that I told you last time also. The magazine currentconservation.org. Did you get a chance to look at the magazine? Okay, so there are like a number of issues right now. I think you can pick whichever looks beautiful or pretty or something, and you can go through it. But this one is in the turtle, something about plastic and turtles. So this one, this information was from there. Okay. Although it says microplastics, it's actually not true. It's not less than 5 micrometer. It's actually less than 5 millimeter. So A is the answer. So I know the questions right now are very technical, but there is also something that I am not exactly very Um so the module was human ecology, and no, sorry, module was something global change or something. So I'm not the best one to. I mean, I'm not exactly environmental scientist or something. So it's become more technical in that sense. But yeah, yeah. Question 5. Yeah, from here on, I have put a little more of ecology into it, which is more my zone, my comfort level. Hmm. You you almost you're missing out on all the answers today. Anyways, it's good only, I suppose. Yeah, D is the answer. So first A is basically everyone knows they are visual feeders. No, I mean everyone does know they are visual feeders, but they mistake plastics for jellyfish. So that is I think very famous now. People know about that. Second is herbivores. Yeah, they if ingest a microplastic stuck on the fronds of the sea grasses. So herbivores like the uh, not the olive ridley. What is the green turtle? Then the carnivorous ingest. I mean that's a famous one where plastic gets ingested because they eat something else that ingests plastics before. So that's also very common in terrestrial ecosystems. So it's not just in the marine ecosystems. But D is something that is not known. Like turtles don't directly feed on microplastic from the bottom because turtles are generally not bottom feeders. They are either herbivores, jellyfish eaters, or herbivores, seagrass eaters, or they eat prey that are mostly swimming in the ocean. I mean, in the sea or the ocean. So bottom feeding is something that turtles are not seen doing. So yeah. Okay. Okay, so I created all these questions because I would just, I mean, it's not, I'm not interested in knowing how much you know. I just want to share with you whatever I know. So that's why I created all these questions. So these questions are not exactly, I mean, don't expect these questions to come in the exams. So they are just so that I can, I mean, whatever I know about ecology is something that I throw it at you. I mean, throw at you because you are anyways going through the lectures of Professor Ankur Awadhiya and all. So yeah. So yeah. Okay. So the answer is D. Sorry. They do, I mean also again they are not known to ingest floating plastics like that. But A is very interesting. The option A is very interesting, where the turtles once hatched. I mean, as you might already know, turtles once hatch, they reach the sea, and then they once they reach the sea, they nobody knows what happens to them until they come back again, like several years later, to again lay their eggs on the coast. So generally, what happens is these young turtles are pushed to certain areas by the currents, the ocean currents. I mean, you might have seen it in the movies like Finding Nemo or something. Yeah, they show these ocean currents taking away a lot of other animals. So similarly, turtle hatchlings are also flown away, and then these currents converge to an area called one of those highly productive zones. With so and But what happens is these also have a lot of plastic debris in those zones, where these turtles start living in those plastics and eventually ingest a lot of plastics from there. Then Pacific garbage patch. Then yes, that young turtles are more naive to distinguish its food from plastics, and yes, they also have smaller and less robust digestive systems. So this is basically so there's a microplastic less than 5 mm and there's a macroplastic greater than 5 mm. So the greater than 5 mm usually gets stuck in their trachea or in their windpipe or food pipe or something. So until they have a robust digestive system, it's difficult to it's difficult for them to remove or eliminate it out of the systems. So D is the answer over here. D is something that is not true. So yeah, I'll take the next question, 7. Yeah. What do you mean? Sorry. No, D is not true is what I'm saying, yeah. Oh, I'm sorry. Oh, yeah. Sorry. I'll change the question. Yeah, young turtles. Okay. Sorry. Okay, I can't. For what reason might a young turtle not be more vulnerable to plastic pollution? Okay. The question was supposed to be like that. I'm sorry. So, yeah. Okay. So Rayhanun, you say D or A. Amita, if you want to answer, you can answer. Sorry, I couldn't hear you. If you wanted to say something. Did he say something, Amita? Oh, okay. No, answer is actually D, sorry, all of the above. Plastic can affect in a lot of ways. Entangle is the most common one that people usually see in advertisements and warning displays, etc. But egg laying patterns, so if the beach is too littered with plastic, the females might refuse to go onto the beach to lay the eggs. So, and these beaches are something that they have so they come, as you might already know that turtles come back to the same beach where they hatched. So if that beach has changed a lot and it remembers the same beach, so people don't know if they'll come back to the same beach if the beach changes in its visuals. So that is one thing. And then the other thing is sand temperature. So it may affect all the plastics in the sand may affect the temperature. which can affect the sex of the turtle hatchling. As you might already know, the temperature of the sand affects the sex of turtle hatchlings, crocodiles. A lot of animals, the sex may get affected because of the temperature of the sand in which they are buried. So that is something that, yeah, people were unaware of for a long time. So yes, mostly reptiles. So the answer is D in this case. I'll go to the next question. So RCP is basically a concentration pathway, which will tell you how the CO2 equivalent. So basically, amount of CO2 in the atmosphere, how much is it increasing with the passing years. So if you look at the graph over here, you have CO2 in the y-axis and the year in the x-axis. So different RCPs show different situations, where this particular point is the current situation from 2000. So we are here somewhere. Yeah. So different RCPs are showing you how CO2s might differ, in which this is one way where you are actually taking actions to control greenhouse emissions and stuff like that. This is a second way where your actions are not very I mean, the green is where this is the strictest actions are taken. Purple is strict but not very strict. Brown is not so strict at all. And the red line is basically you are not taking any action and letting it be the way it is. So these are 4 RCP pathways. There are 2 more. There's 1.9 and I think there is one in between. I don't remember, 7.5 I think. So anyways, that is all okay, but what does this 2.6, so this is basically RCPs are used in predictions. Basically, if people are talking about future, about anything, say for example they are talking about how land use or land cover might change. This has nothing to do with carbon. This has RCP is not just about carbon dioxide. So based on this, people can talk about a lot of things. So say for example, people can say climate change may affect the grassland or the forest cover on the earth. So they can say that if we are taking RCP 8.5, grassland may get affected more. If we are taking RCP 2.6, grassland may not get affected more, but it may get affected in the middle, but it may eventually pull back and get together. Basically the impacts may get reversed in several or half a century or something like that. So that's RCPs are used a lot in future prediction. So yeah, so basically all of them are named based on something. So that's what I'm asking. So you think it's predicted increase in global temperature? No. The next slide will tell you RCP 2.6 has a very different predicted increase in temperature, whereas RCP 8.5 is also a different increase in temperature. This is basically the radiative forcing values in the year 2100. What is the radiative forcing? So sun is throwing some amount of energy onto the earth, and some amount is thrown back into the space because of reflection from the sun. Some amount is absorbed into the sand, into the earth, and some amount is absorbed by the water, but some amount is actually absorbed by the atmosphere, and it is stored in the atmosphere, which increases the temperature of the atmosphere. So with the increase in carbon dioxide, the radiative forcing is basically the amount that is actually absorbed into the earth, which is not released back into the space. So that is radiative forcing. As the carbon dioxide increases in the atmosphere, this radiative forcing also increases because carbon dioxide is a great absorber of heat. So that is what radiative forcing is. So it's the value is in watts per ton per meter cube or something like that. So this RCP 2.6 is basically radiative forcing of 2.6, and RCP 8.5 is radiative forcing of 8.5 watt per ton per meter cube. So the answer is A. I hope you got it. Yeah, okay. The next question. So yeah, the next question is where it is. RCP 8.5. What would be the likely increase in temperature? No, this is RCP 8.5. 8.5 is like the worst possible scenario. 1.5, we have already reached 1.5 degree greater than the previous this thing. Yeah. No, the answer is actually D5. Yeah, Amita is right over here. 5 degrees Celsius is what is predicted to be. It increases more. 5 degrees more in the future by 2100. So the answer is D5. I'll go to the last question. Yeah, here. So RCP 1.9 is 1 to 1.5, which is the best possible scenario. And then the second possible scenario is 1.5 to 2. 8.5 is basically an increase of almost 5 degrees Celsius. This is based on pre-industrial baseline. So that is basically before 1850. I hope you got it. Yeah. Okay, I'll move to the next question. Yes, Amita, you don't have to raise the hand. You can just talk if you want to. You want to say something, Amita? Okay. Okay, I'll just go to the next slide because I don't remember the answer though. Yeah. Okay. So 8.5 is 0.63 meters. Yeah, meter increase, which does not seem very much, but if you take the Earth's digital elevation map, so that the DEM, digital elevation map, is basically a map that tells you the elevation of each point on the Earth, and if you take that and remove everything below 0.63, you will find that a lot of coastal areas get submerged. So it doesn't seem very much, but RCP 8.5 can actually remove almost about 20% of the land cover. I'm not sure of the figure, but yeah, somewhere 20% of the land cover, terrestrial part of the Earth may get submerged in water. So the answer is 0.63. Here. Yeah, A. Answer is A. So this is all the question I have. Amita, I can repeat the question if you want to. Do you want me to repeat the question since you have come late? The ones in the beginning. Amita? Okay, sorry Raihan, I'll just repeat the questions for her. Anyways, we are like at the end of the questionnaire, and yeah. So Amita, this is the first question. If you want, you can try and attempt this question. Rehanul, if you're okay, you can leave the session, but but if you want, you can stay back till 7. So yeah. Okay, sure. Thank you. Bye. Amita, you want to attempt this question?
Sir, repeat question.
This, sorry, what?
Sir, question सारा repeat.
सारा नहीं कर रहा मैं, सिर्फ 1 से लेके 6 तक कर रहा हूँ. यू वर देयर?
Yes, sir. Yes, sir.
हाँ, तो अभी
Yes.
फर्स्ट क्वेश्चन यही है.
Yes, sir.
तुम्हारी स्क्रीन पे है, पढ़ के देख लो. क्या लग रहा है तुमको आंसर? बी. सो नहीं, हम तो एक्चुअली बी नहीं आंसर. सो बेसिकली ऑयल स्पिल में specific gravity is basically the density of the substance divided by the density of water. The density of water is roughly 1000 gram per, no, 1000 कितना, 1 gram per centimeter cube. That is the density of water. So अगर specific gravity greater than 1 है तो इसका मतलब the substance is heavier than water. So that means the oil spill अगर का specific gravity greater than 1 है तो that would mean the hydrocarbon would sink in the ocean. अगर less than 1 है तो that would mean that they will float on the ocean. So what happens is when they float on the ocean, what happens is they get exposed to sun. So that gives them a chance for them to break down because of the UV rays of the sun and because of atmospheric conditions, rain, etc., etc. But so then it becomes less harmful for the environment because it breaks down into more less harmful hydrocarbons. But what happens if the specific gravity is greater than 1, they sink in the water and then they reach the bottom of the earth, and thus they become a problem for other animals. So the answer is A, not B or C. They do not get exposed to sun, and hence they don't get broken down into simpler and less harmful substances. Understood?
Yes, sir.
Okay. The second question screen पे है. No. The answer is A. Okay. So biomagnification is basically how with each trophic level. So basically, biomagnification is like pesticide or other harmful substances in the soil will be taken in by plants, say for example, and it will store it in the leaves. Then some herbivore, grasshopper or something will come and eat the leaves, and that will get stored in the fatty tissues of the grasshopper, say for example. Then so the grasshopper is eating only grass, so, and if it's eating of that area, then the concentration of the pesticide would increase in the grasshopper. Now say for example a rat eats the grasshopper, so that gets stored in the fatty tissues of the rats, and because it eats only grasshopper, so there the concentration of the pesticide would increase furthermore. And say for example it is eaten by some predatory bird or something like a shikra, the rat. then what happens is that would further accumulate in the bird's fatty tissues, and that would create a lot more problem because the concentration just increases as you go to the higher trophic level. So over here, trophic level, the first one was the primary producer, then the primary consumer, then the secondary consumer, and then last was the tertiary consumer. So it is increasing trophic level. So answer is A. Did you get it, Amita? The next question is there on the screen. It's a very technical question, so even if you don't know the answer, just guess anyone. Okay, so the right answer is C, 9%. So, I mean, the plastic is not recycled that much globally, but 9% is still a good number comparatively. I'll move on to the next question. Yeah. No. Size of microplastic is something that is it's basically defined as less than 5 mm. Yeah, greater than 5 mm because macroplastic. So it depends on the animals. Like microplastic is something that certain animals are okay ingesting in, but macroplastic becomes harmful for certain animals. Some certain animals cannot interact with macroplastic at all because they are much larger than them. So like that. So the answer is A over here. Next question, fifth question is on your screen. Yeah, perfect. The answer is right. Turtles are not bottom feeders, so they don't ingest microplastic from the bottom of the floor of the ocean. But they are definitely visual feeders. They mistake plastic for jellyfish. Then they also intake plastic from the fronds of the seagrasses, the herbivore turtle basically, like the green turtles and all. Then there is carnivorous turtle, which ingest crustacean and mollusks which have already ingested microplastic. So that further increases microplastic content in the turtles. So yeah, the answer is D. You're right. Last question. From here on, you have seen every other question. So basically इसका सवाल का मतलब ये है कि young turtles are vulnerable to plastic pollution. So three there are three reasons over here which and there is one reason which is one statement which is not true, and three reasons which are true and which says that they are the reasons why young turtles are more vulnerable to plastic pollution. So which is the statement which is not true? No, actually D is the statement which is not true. Turtles are naive. They cannot distinguish food from plastic sometimes. They have smaller and less robust digestive systems as well, and also as you may have seen it in movies like Finding Nemo, where there are currents that take animals to certain areas. Young turtles, when they hatch, they go back into the ocean, and these currents take them to certain areas, so where all the currents come together and merge. So these areas are also where the plastics come and settle. So that is where the turtles start living in these places, and they might ingest plastic. So yes, so A, B and C are true, D is untrue. So yeah, that is the end of the session. I only have these many questions. Thank you for coming, Amita. I have not seen you before in this class. Okay, so I'll end the session then. Thank you again. Bye.